Hi guys, welcome back. Today we are answering questions from grade 10 about waves. So we have 5 questions today. First question is coming now. What I'm asking from you, please try first. Okay, this is our question. 1.1 is here. Please take your time, try first, and then we can answer together. Okay, let's see our question, what they said. We have waves, and then they said distance between a crest from highest level to lowest level, 3.2 centimeters. That is given. And total time for all waves together making 0.21. Asking you how many full waves are there between 0 seconds to 0.21 seconds. You are going to just count how many waves we have. Question 1.1 will take your 5 seconds, I think. Please count first, and then we can carry on. If you need extra time, please stop video, and then you can carry on. But otherwise, I'm going to just continue and answer question 1.1. How can we answer this question? They ask you how many full waves, how many cycles we have for this wave. What we are going to do, you must check our pulse. First pulse, positive pulse is coming here. This is half wave. And then negative pulse together, making 1 wave. All right. Positive and negative, 1 wave. Another positive and negative we have. Let's check. We have another wave here. Positive and negative, making 2nd wave. And we have 1 more wave. Let's see that one also here. Positive and negative wave, positive and negative pulse, we can say. So our answer is 3 full waves. 1, 2, and 3 waves. 1.1. Answer is 3. Taking time. Let's continue. So next one, question 2. Question 2. Now, use this all information, and then what is amplitude? Okay, this is another easy question. Now you know distance from crest, from highest point to lowest point. Distance, you know, 3.2 centimeters. Asking you amplitude. You should remember what is amplitude. Please take your time and try to get your answer. Question 1.2, asking amplitude. Okay, I hope you're done. You did try. Now, let's continue with amplitude. Amplitude is distance from rest position to the crest. So this, or from rest position to throw just lowest point here, giving you amplitude. But they said from crest to throw all this distance, I couldn't draw a straight one, but this distance from crest to throat, 3.2 centimeters. So we need only half of this, because from rest position to crest or from rest position to throat, lowest point. So just half of this is giving you amplitude. Okay, let's write our answer. Amplitude equals 3.2 over 2 is equal to 1.6 centimeters. If you need in meters, divide by 100, 0.016 meters. This is our answer for amplitude. All right, so today what we remember, amplitude from rest position to the highest point. All right, so let's continue with next question. Let's see what else they're asking you. Now they're asking calculate period. Calculate period of the wave. Okay, all time, total time is given for 3 waves. Okay, after that, you are going to calculate period of the wave. Please take your time and try first. If you try, you can learn. Otherwise, it is difficult to learn. Please take your time. You can stop video and then you can try. Normally, other videos I was giving time to try, but some learners, they just want to listen. Some learners, they are trying and answering so quick. Some learners taking time, so we cannot just give time, specific time to answer these questions. Please just take your time, 1 minute, 2 minutes, 1 minute or 2 minutes, you can try. maybe maximum 5 minutes too much. Yeah, 5 minutes too much. Just try. First, take your time. All right, calculate the period of the time, period of the wave. Let's calculate. First of all, what we know, how many waves we have in question 1.1, we done already. We know n equals 3 waves, 3 cycles. And then your time is 0.21 seconds. We can calculate period of the period equals time, total time for all waves together, divided by number of waves. Our total time is equal to 0.21 seconds over number of waves is 3. So you are getting 0.07 seconds. Please don't forget to write unit. If you forget unit, unfortunately, you are losing your mark. Okay, you can use this method to calculate period. 1.3, done. Let's continue with next one, 1.4. Now, wavelength of the wave is 0.4 meters. Calculate speed. Now you know period, and then wavelength is given. They ask you calculate the speed. You know our rules. We must stop and try first. Please stop and try, stop video and try first. And then when you get your answer, please come back and check correct answer. So that's our plan, that's our rule for this video, this our lessons. Please use that way to learn. All right, if the wavelength of the wave is 0.4 meters, calculate the speed of the wave. Okay, so let's write all givens what we know. Number of waves, 3, we know already. I don't know we need or not, just write what we have. Period we calculate 0.07 seconds. And then what else we know? Wavelength. Wavelength is equal to 0.4 meters. Okay, let's check our formula. Which one is best to calculate this kind of questions? We can use which formula? Let's check. This formula will help you. But we don't know frequency, but we can use this formula we can use 2 steps to calculate this question, or just 1 step. Okay, we are looking for speed. Speed equals, from formula box, we have frequency times wavelength. But we don't know frequency, but we know frequency is equal to 1 over t. Check this formula. T is equal to 1 over f, so can we say frequency is equal to 1 over t? All right, just swap. All right, so frequency is equal to 1 over t. So we can write our formula, wavelength over t. V, speed, is equal to wavelength over period. So wavelength is 0.4 over time, period, time taken for 1 wave, period is equal to 0.07, and we can get our answer. So 0.4 over 0.07, 5.71 meters per second. All right, to calculate speed, we are using formula from formula box, just getting it. V is equal to frequency times wavelength. And then for frequency, if you want, you can just calculate frequency by using this formula and then just put it here. But with 2 steps, we don't need that. Just we wrote for frequency 1 over t, and then we calculate. Always, we are reminding you, please don't forget to write units. All right, let's continue with next one. Let's see what else we have. All right, question 2. Now we are going to question 2, 1.4 done. Question 2 is coming now. Calculate the energy of a photon with frequency 5 times 10 to the power of 28 Z. Frequency is given, asking you energy. Simple question. You can get formula from formula box and you can calculate it. So you know our steps. Please stop video and then try first. All right. I hope you just stop video and then you try. So when you get your answer, we can carry on with our solution. Energy of a photon with frequency 5 times 10 to the power of 28 Z. Okay, our formula is here. That's it. E equals H times F. I hope it's clear. So H times F. And then, guys, H is 6,63 times 10 to the power of negative 3, 4. What's going on? So this number coming from constant numbers from formula box. It is Planck's constant. It is our constant number. We are not taking units, just number. We are taking our constant numbers list and then writing here. So 6,63 times 10 to the power of negative 3, 4 times frequency is given 5 times 10 to the power of 20. And when you multiply these big numbers, one is too small because negative 3, 4. So we said big number, but it is too small. And then other big number, we have 5 and 20 zeros. So energy, when we calculate, we are getting 33,15 times 10 to the power of negative 1 for unit joules. Please don't forget to write units. Just think about that. This is 3 marks question. 1 mark coming from formula. Just getting formula from formula box. 1 mark for substitution. 1 mark for correct answer with correct unit. Because of that, I'm reminding you, please write unit when you're done, when you answer your question. Okay, question 2, also done. Let's continue with next question, guys. Please try first. Always we are saying, we are reminding you. Okay, let's see our question first, and then take your time to try. Now, wavelength is given, and then asking you calculate energy of photon. Okay, we have another formula here. Okay, just you can just calculate energy. Please take your time to calculate. We are looking for energy of photon. We are looking for energy. Now we know wavelength. All right, I hope you're done. So I'm not waiting because I believe you just stop video and then you did try, you have your answer, and then we carry on together. All right, so now we are looking for energy of photon. So formula is E is equal to hc over wavelength. Why not h times f? Because we don't know frequency. Now we know wavelength. If you want, you can get frequency from this formula, and then you can make 2 steps, but we don't need. Why we are making difficult life for us? So let's just use formulas here. Let's use one formula and make it easy life. So E equals h times c over wavelength. So what is h? What is c? We know already here. This is c, this is h. They are constant numbers, and wavelength is given here. Just substitute, just write all numbers in the formula, and then you have done. So 6,63 times 10 to the power of negative 3, 4 times speed of light 3 times 10 to the power of 8 over 3 times 10 to the power of negative 2. We are writing all numbers in the formula, and energy equals, when you calculate all these things, you are getting 6,63 times 10 to the power of negative 24 unit joules. Without unit, 1 mark is going. You can say bye-bye to 1 mark. Please write unit. All right, another question, done. First question, they give you frequency, and then you calculate energy. Now, wavelength is given, asking you calculate energy. Let's see next question. Let's see what they ask. So next question, energy is given, asking you wavelength. Good luck, guys. Please try first. You are trying, you stop video, and then we are going to answer together now. All right, we can start. So wavelength of a photon with energy 3.3 times 10 to the power of negative 9 joules. Okay, wavelength, we are looking for wavelength. Energy is given, so we can use this formula. Let's check our formula first. Let's see what formula can we use. Okay, let's change color, use this one. Okay, so energy equals h times c over wavelength. But I know energy, I need wavelength. Can I swap these two? Of course, with just E and wavelength. If you want, you can use this way. E times wavelength is equal to H times C over, so divide by E each side, E. So if you do that, E cancels. So wavelength is equal to H times C over E. You can just swap these two, and then you are making another formula. So wavelength is equal to H times C over E. Wavelength is equal to H, we know it is constant number 6.63 times 10 to the power of negative 3, 4, and times by speed of light, 3 times 10 to the power of 8 over energy is given here in our question, 3, 3 times 10 to the power of negative 9 joules. For unit, we are not writing just doing substitution, girls. Boys, we are just writing all numbers, not units. All right, substitute all numbers. And then when you get your final answer, of course, we have to write unit. Wavelength, after all calculation, what are we getting? So 6,03 times 10 to the power of negative 17 meters, not joules anymore, because you calculate wavelengths. All right, you can mark your question. You can just check your answer and you can mark it. So I hope you are getting full mark. This question also another 3 marks question from formula 1 mark and substitution another mark. But sometimes some memorandum giving 2 marks for this substitution on top and another one, but mostly formula 1 mark, substitution 1 mark, and final answer with correct unit, another mark. Okay, let's continue with next question. So let's see what we have on next question. Write down the names of EMF electromagnetic spectrum, EM spectrum, in order of increasing frequency. So we should know all EM radiation, all lights, just waves in order, because they ask too many questions about that. So you must just know them, you must memorize them in order. So longest wavelength, lowest frequency, last one with shortest wavelength, highest frequency. Okay, take your time. Please write them in order. Okay. Just a few seconds. You are going to stop video and then you are going to try. All right, let's continue. Now, all in order. So our first wave is here. So first one, special. It has longest wavelength. And then second one, third one, and number 4, number 5, 6, and 7. You see in order, this one has longest wavelength, and then this one is shortest wavelength. And then if you move from first one to next one, frequency increasing, but wavelength decreasing, getting shorter, shorter, shorter. All right, so we have done for today. I hope you are getting waves topic. Everything will be good. Good luck for your test. Everything. See you next lesson. We have done for today. Thank you very much. See you next lesson.